All right, let's get started. Welcome everyone to the webinar, How to Design, Automate, and Deploy a Cartesian Palletizer with Vention and Joulin. With me today, I've got Patrick Tawaji, Head of Applications at Vention, and Philip Hart, Business Development at Joulin. In a moment, I'll pass the reins off to them to introduce themselves, but before that, a couple of housekeeping rules. This webinar is being recorded, so a version will be available on demand afterwards and shared with everyone who attended and could not make it. Everyone is on mute, but please share your questions with the Q&A box at the bottom. We'll get to those at the end of the webinar. And really looking forward to having everyone here and hearing their thoughts. So I'll quickly pass it off to the speakers to introduce themselves before we get into how we're going to roll out.
Great, Jen, thanks. So like Jen said, Patrick Tawaji here. I head over the applications team at Vention. So what that means is we create the designs, the guides, we do the testing on what we call applications. So these kind of machines that are built up off of our modular building blocks. I'm really excited to be here and speak alongside Philip Hart at Joulin, who are some of the experts in gripping solutions for what we're going to talk about today, which is Cartesian palletizers. And just as a quick note about Vention, we're a manufacturing automation platform for everyone, right? So you can use our online CAD. It's a free tool called the Machine Builder to basically configure, design, automate your machines all from a single environment and actually get the entire machine all at once. And we'll talk a bit more about that later. Philip?
Thanks, Patrick. Hey, I'm Philip Hart from Joulin. I've been working with Joulin for about 4 years, been in the automation industry about the same. Joulin's been around for over 60 years. We build vacuum gripper systems for the lumber industry as well as the packaging industry and everything in between. And this is going to be really great. The partnership between Vention and Joulin is really exciting. We both have very modular style systems, so we can take standardized systems and put them together to create a really nice automation system for you. So really looking forward to kicking this off. Thanks, guys.
Thanks, Phil. So a little bit about the webinar at a glance. We're going to kick off with how to evaluate your Cartesian Palletizer project. Then we'll move into configuring your actual palletizing cells, so best practices, guides, and tools of practice. Then we'll move on to configuring the end of arm tool, and that's where Phil will take us forward. We'll close up with how to deploy your Cartesian Palletizer now that you've configured both the cell and the end of arm tool. And finally, we will share some case studies from the shop floor, which we've been able to deploy together as a partner. And of course, we're saving 15 minutes at the end for all the Q&A. So as a reminder, please submit your questions at the box below, and we will get to those near the end. Without further ado, I will pass it off to Patrick.
Thanks, Jen. So as Jen mentioned, let's take a look at first evaluating your Cartesian Palletizer project, right? So we want to discuss the common drivers that you would have when you're evaluating, your factory, your process, and trying to decide, should I be doing this or not? What is automated palletizing, et cetera. So first, let's provide a bit of context, right? What is palletizing exactly, and where does it fit into this whole packaging process? So as we can see in this image here, this is obviously a very automated line, right? An automated factory. Not every factory looks like this. We see everything from fully manual up to this. Palletizing can still make sense for basically all of those cases. And like we can see here, palletizing is one of those last steps, right, in the packaging process, when the product is already kind of in its final format in a box, ready to be shipped. And it's that final step, often very repetitive, where you're basically just putting boxes or product onto a pallet into its final shipping format. Maybe there's pallet wrapping after, before it ultimately leaves the factory, right? And so this is at the upper end of automation, right? But like I mentioned, this can still make sense for something that's a little more manual. So now that we know what palletizing is, why would you want to automate it, right? What are the drivers behind that? And as we can see from our friend here, it's just not a good time, right? But no, all jokes aside, you might want to be doing this because it's so simple and it's actually one of the low-hanging fruit, right? It's a repetitive task. There's actually little added value by a human operator to be there doing this task, right? It's something that can easily be automated. So that's one reason, obviously. The fact that it's so repetitive and dull can actually make it dangerous, right? This kind of repeated motion can lead to injuries and errors as well, right? It becomes a little too rote. And then as well, if there's heavy boxes, I mean, it's can be very easily unergonomic, right? You're kind of constrained by the size of the pallet ultimately for where people are going to kind of be reaching and placing things. So that can also, lead to a high risk of injury. And ultimately, that just makes it hard to find and retain labor, right, for this manual palletizing task. So that's kind of the first main driver, right, is kind of just the nature of the job. Another consideration that we found as we've engaged with customers that's extremely important and extremely relevant is that at those lower throughputs, it can be extremely disruptive to operations, right? Most typical palletizing solutions, are built for extremely high throughputs. That's a no-brainer to automate. Otherwise, you need basically a small army of operators to keep up with the actual needs of the palletizing operation. But low to medium throughputs can still be fairly disruptive to operations, right? And it can be kind of hard to justify dedicating an employee to the task. So we've actually built an example here. I don't want to really stress and go into all of the details of everything, but just at a high level, right? We've built a hypothetical example where we have 4 boxes per minute, right? So the operator kind of has 2 choices. Either they're going to wait every 15 seconds for a box to come before placing it on the pallet. Those 15 seconds are kind of wasted time, right? Or they can maybe wait for a few boxes to accumulate before placing them on the pallet. And that's actually what I've outlined here. So those those yellow blocks is a situation where the operator is waiting for 8 boxes to come to the end of the line before stacking them up on the pallet. And let's just assume, I don't know, maybe when it gets to 8 boxes, it starts to back up the rest of the line, right? So they have to come back. 8 boxes at 4 a minute, that's actually only 2 minutes, right? So that's not a whole lot of time for the operator to be doing anything else, right? Especially if they have to go walk to another station. Doing all of this context switching, how useful can they actually be in those 2 minutes? One of the risks too, since this is so periodic, is you're essentially having to maybe you're going to forget to go back to the station, right? And if 8 is the maximum that we've said can be accumulated in a buffer zone before you start to have issues with the rest of the production line, well, that's going to start to be a bottleneck for the rest of the operation, right? So automating palletizing is essentially a way to free up that operator, repurpose them somewhere else where they can actually spend a good chunk of time somewhere else, and then they might just have to go back and maybe swap out the pallets, once a full pallet is full, right? So that yellow block is going to be much longer if you're able to automate palletizing. And there's even solutions for automating pallet feeding and pallet outfeed, right? So those are even things you can consider if that's still being too disruptive for the rest of your operations. So those are 2 pretty strong motivators to automate palletizing. Ultimately, though, right, at the end of the day, it's all about the business case that you can build around making a capital investment like this, and if you're ever going to break even on it. So at Vention, we've created a very simple return on investment tool, or ROI tool, with a few parameters that we can tweak so that it matches up with your particular scenario as closely as possible. And so this is going to be used to calculate your expected payback period, right? And so we have a team of experts here, right? We have account executives and application engineers that can help you configure that for your particular scenario. And for a typical scenario with a dual pallet setup, kind of like what we're seeing here, running 2 shifts a day, it's a really straightforward business case where you can actually break even in less than 12 months, right? It's obviously making a few assumptions, but that's a good rule of thumb. So now that you've hypothetically made the decision, right, that automating palletizing makes sense for you, you're saying, let's do this. What comes next, right? Obviously, now we need to configure the palletizing cell. So it's basically a bunch of decisions that we have to make on equipment selection and configuration so that the cell is adapted to the particular environment it's going to go in. So first off, we kind of had this decision to make between the overall architecture of the system. So we have these Cartesian gantry palletizers on the left, obviously what we're focusing on here, or robot arm palletizers. And what we're seeing here is actually more of a collaborative robot arm palletizer versus those more traditional ones that we need large safety fencing around them and everything. One reason why you'd go with one over the other, footprint is lower on the right with those collaborative approaches, but the payload is going to be more limited, right? So if you have larger boxes or really large unwieldy products, even if they're not too heavy, you might want to consider a Cartesian gantry palletizer to do that. All right, so that's just some of the considerations that I'll go into. Why would you choose one equipment over the other? There really isn't one that's better than the other. It's really just what's more adapted to your particular use case. All right, so for this example, we're obviously assuming we've selected the Cartesian gantry palletizer. Let's say that I have something that's just too heavy for any of the cobots that I can find on the market. And next up, you still have a bunch of options to select from for Cartesian palletizers, right? So there's the single pallet setup, the double pallet setup. You can actually put more pallet bays. It doesn't increase cost that much more. The most common one is the dual pallet setup. It's actually marginally more expensive than a single pallet setup, and the efficiency gains you get in terms of operations, it's really easy to justify essentially going with a dual pallet setup because basically while you're swapping out one pallet, we're able to have a safety scanner on the front of that lets you actually go swap out the pallet that's not being worked on and that's already been filled, right? So really easy to justify that actually. So that would be the first step. And then there's a bunch of other criteria and considerations that go into this, right? So foremost is the product characteristics. That's why we have Joulin here, right? That drives a lot to do with the end of arm tool selection. So what is the actual product that's going to be picked? Corrugated boxes? Is it bags? What are the bags made of? How porous is the material? Are they open top boxes? Are they trays with cans on them with kind of a funny geometry on the top that we have to adapt to? All considerations that have to be taken into account. The pallet characteristics, obviously. So what's the size of your pallet? Are you something standard? Is it going to fit really easily in a standard configuration? Or do you have a custom pallet size, right? Something a bit longer that we have to take into account. The stack height, so we can accommodate up to a certain stack height. Past that, it might be a little more customized design, but then we can also kind of, if there's not too high of a stack height, we can reduce the overall machine height and reduce the ceiling height requirements, for example. And then obviously the pattern, right? Do you have a very simple pattern and we're just picking and placing very simply, or do we have to rotate boxes as we're going? And is the spacing very important between the different layers? And do we have to change patterns as we build up and put slip sheets just so that we can have a stable pallet, right? So those are questions to ask yourself as well. What is my actual pattern? The in-feed options, so we saw on the previous slide actually that the conveyor was coming in from the left, but you can actually choose that location, right? From the left, from the rear, from the back, from the right. And the type of conveyor, what's going to be best suited to transporting the product, a belt conveyor or a roller conveyor, or I don't know, something else. There might also be options for accumulation or buffer conveyors, right? So if you want products to stack up at some point because, I don't know, maybe you're doing a multi-pick, right? Picking more than one box at a time, or you want accumulation. So you have specific spacing between the different boxes or the different product because you need to do a scan with a vision system of some sort. So again, questions that have to be asked. And obviously the environmental constraints, right? So where is this equipment physically going to go in the plant? What's the available floor space? Even if there's an in-feed conveyor on the conveyor, obviously on the palletizer, obviously that has to be fed from somewhere else, right? So how is the palletizer interfacing with the other equipment already there so that we can ensure, a smooth throughput, right? So 4 important characteristics there. And then a few more options to select from here. So I've highlighted grippers here really, and I'm going to hand it off to Philip pretty soon to talk more around that, but that's extremely important, right? When we're talking about configuration, these machines will work for just about anything. Most of the design on them is already done, but what's going to change every time is what product is actually going in there, right? And it's just so important to be able to select the right end of arm tooling. Foams versus cups. Can you use something off the shelf or something more custom if your product's a little more funky? And are you going to be doing multi-pick, right? So the machine has a maximum throughput that it can take, but if you have a simple enough pattern and if your products aren't too large, you can actually consider multi-pick. So let's say I pick 2 boxes instead of 1. I mean, the math is simple, right? I'm going to go twice as fast, right? More or less. And then there's other add-ons, so a tower light that can indicate the machine status, the area scanner like we saw in the front. You could actually have that more as a gated type system with an interlock switch for safety, all the different sensors that go around for machine monitoring. There's air and power supply, obviously, so where's the cable routing going to go? If it's a pneumatic gripper that needs to generate a vacuum, are you going to need some kind of air filtering from the compressed air with an air pump if you need to provide a blower system for whatever reason. That's something that has to be taken into account. And then finally, there's kind of those extra features like barcode scanning. If you need to scan and have it integrate into an ERP system, those are options that can be added. And finally, box locating, right? So making sure that anytime a product gets fed into the palletizing cell, we're going to be able to go pick it repeatedly at exactly the same spot within a certain tolerance so that it gets placed on the pallet. And so, we're not going to hit the other products that are already on the pallet, and that we build up a very stable pallet, right? Very important. And there's a couple different ways to do that. The simplest is mechanical locating, obviously. The cheapest as well. That's actually the preference all the time for most of the cases. But you can also consider things like vision-based system that will automatically identify what's the orientation of the product, right? Which might be desirable for a variety of reasons, maybe speed or not being able to locate the product properly for whatever reason. So all considerations to take into account. And so for this next section, I'll pass it up to Philip, who can talk to us a bit more about selecting and configuring the end-of-arm tooling.
All right, thank you, Patrick. Well, hello everyone, and welcome to this collaborative webinar between Joulin and Vention. Today, I hope that this provides an educational experience so that you can be as successful as possible in your next project. I'm really excited about the partnership that we've got with Vention, or that Joulin has with Vention, because I really believe that between the two of us, you can utilize a system as a whole that's really going to be effective for palletizing specifically, like we're talking about today. So just to give you a little bit of background on Joulin, Joulin's been manufacturing innovative vacuum handling systems for over 60 years. In 1968, Michel Joulin created the world's first foam vacuum gripper. We actually started in the lumber industry in France, manufacturing large gantry systems to handle large layers of rough lumber. And in that environment, we really had to establish a system to manufacture robust grippers that could withstand the harsh environments and also pick difficult products. In the early 2000s, John Eldridge actually started Joulin North America and began selling Joulin gantry systems here to the furniture factories. And when the unfortunate events that occurred in 2008 happened, the furniture market essentially just crashed, as many of you may know if you're on the eastern side of the United States. And when that happened, Joulin had to kind of shift its focus from being a gantry manufacturer and a gripper manufacturer for just the lumber industry, and really had to shift that over to all types of industries and packaging and so on and so forth. And so that's what we've been doing since the early 2000s. So what makes Joulin unique? Joulin has been known for years for very robust systems that require very little maintenance. We have no filters or no screens on 99% of our grippers because we just really don't need them. And we have expert customer service. So you call in, you ask us what you need. Similar to Vention, we're here to work with you. Customer service is a really big deal to us, and we really want to provide that service to our customers as well as our robust systems. So let's just talk about the difference between some of our grippers. So there's going to be a few different types, but essentially what we want to do is help you to kind of see an overview of how you would want to define what you need for your project. So we've got some valve grippers, some check valve grippers, and some port grippers. And the main difference is a port gripper is going to be a metered port style system that's going to have a bunch of holes in the gripper essentially. And essentially what that means is it's going to enable you to be able to pull vacuum on the product. One of the benefits to having a port gripper is going to be that you can rotate the gripper 360 degrees all the way around without having to worry about losing the product or losing vacuum. It can be a very high speed application because you don't have to worry about closing check valves. So you can immediately activate the vacuum. And also they have a thin, lightweight design. So that you can make them very lightweight. You can make them very thin so it has a low profile, and so on and so forth. And some of the things that you need to watch for when you're using a port gripper are going to be the fact that if you have any uncoverage or anything that's uncovered underneath the gripper, it's obviously going to leak. And it's also going to generally consume more air because you're not checking valves and you're not checking those ports. So going into the valve gripper now, a check valve gripper. So essentially in the drawing, like you can see here to the right, we have a little tiny check valve inside of the ports, inside of the ports of the gripper. And essentially what happens is you can have your gripper nearly uncovered or partially uncovered, say half of the gripper is uncovered, and those valves will actually close. And what happens is when those valves close, it seals the air, the vacuum or the gripper off to vacuum, and you're able to still pull really good vacuum on your part. This allows you to be able to pick multiple parts. It allows you to pick large parts and small parts all with the same gripper. Like with the port gripper, like what we were talking about, you need to be mostly covered on that port gripper. With the valve gripper, as long as you can pick the part with the smallest or a small size with the pitch that's available for that specific gripper, which essentially just means how many holes are in a specific area on the gripper, then you can actually pick just about anything with that gripper. And it's really, really unique. So Joulin is going to have a wide range of these types of gripper systems. We're going to have standard grippers, mini grippers, which are going to be similar to a cup. We have flexi grips, which are going to be a little bit larger, all the way up to fully custom systems. So let's move on to actually discovering some of these ported grippers, check valve grippers, and some of the other systems that we have as well. Because most of our standard lines, or most of our standard grippers, excuse me, are going to be able to be modified to any of these based on what your system's needs are. And so as you can see here in the video, or in the picture rather, we've got a collaborative robot picking a box. And this is actually a safe night gripper that we use in the collaborative industry. It's actually a very, very unique gripper because it's built along the same standards and practices that the collaborative industry uses as well. If you're not familiar with collaborative robots are able to move around, and Patrick touched on this just a little bit, but you can work right beside the collaborative robots, which makes them very unique. And what happens is the reason they're unique is because they can actually come into contact with you, and then they come to a stop because they sense that they've come into contact with a human or whatnot. And so we've made these grippers to where they're very safe. They actually are made of 90% foam and then some carbon fiber components for the structure and so on and so forth, so that they can be very robust. But also, you know, if you get hit with one on a robot, or if you're wanting to use one of these in your cartesian cell, then you can assume that you would be safe, because it's basically like a large foam football or something like that. This is going to be a port gripper though. So as you can tell, the gripper is fully covered underneath that box. And so that's one of the requirements that you'll need to have for discovering or to use a port gripper. Moving on to the next slide, you'll see a check valve gripper being used on a large palletizer. These grippers, again, are very unique because you can see this layer of bricks, which this is a very large gripper. So as you can tell, we are picking a full layer of bricks, but there's a lot of areas that are uncovered underneath the gripper. And these areas that are uncovered are going to check, and the areas that are underneath the bricks, or above the bricks rather, are going to stay open to vacuum, and you're able to pull a really high level of vacuum on these grippers. It makes it a very, very unique product because it doesn't really matter where the product is. It doesn't matter what your product SKU is. It doesn't matter what your product size is. Basically, the gripper essentially conforms to what your needs are for that project. So now we'll move down to the bag handlers, or bag grippers. So bag grippers can handle all types of bags with all types of products inside. So whether that's a liquid product inside, or whether that's a loose product like nuts or bolts, or even pretzels or something to that effect. Essentially, these grippers are going to pull the bag inside of the frame and hold it tightly to the bottom plate, allowing your system to move rapidly through its motion profile. And essentially, what that means is it's basically pulling that bag kind of like a pillowcase inside of that gripper and holding that very, 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 very tightly. And then you can move that gripper very, very quickly. Another thing that's really nice about these grippers is that when you go to palletize them off of a conveyor, your bag is going to palletize in a much nicer fashion because most of your weight is at the bottom of the bag. When you release that bag, all of that weight kind of shifts equally onto the pallet and allows you to palletize it very quickly, efficiently, and effectively. The next gripper that I want to show you or share with you is going to be a foam valve gripper. Now, these foam valve grippers are going to allow you to pick open top cans, open top jars, closed top tins, indented surfaces, and many more types of product. We can also pick a pallet with this type of gripper. It's not necessarily preferred, but these grippers are really, all of our grippers are really going to have a wide variety of uses to them. But with a foam valve gripper, this is a very unique gripper because it's a port gripper with a foam on it that is actually acting as a check valve. And it may sound a little bit confusing, but what actually happens is the foam has a small port in it, and it's machined in a way to where if there is an open area, an open space, like you can see in the center of the screen, there's some areas around those cans that are not completely covering the foam. And when you come into contact with palletizing cans and so on and so forth, there's really not going to be a good way to make sure that the full layer is uncovered. So one thing that you may have to do if you were just using a port gripper is you'd have to overcome so much vacuum loss that it would just be a ridiculous system to be able to pick cans. So that's why these foam valve grippers, excuse me, are such a great utilizing system for picking cans and tins. And what happens is it's got a small port in it. And when it comes into contact with the can, that port can either open up a little bit and pull vacuum on the top of that can or that jar. And then it basically creates an entire vacuum area inside of that indented surface. So that's the biggest thing. The nice thing is that if you've got a port that is uncovered, then what happens is essentially it closes up like a check valve and allows the gripper to still retain its vacuum on the parts. So with all these gripper solutions available and with Vention's line of incredible handling solutions, between the two of us, we really believe that we can provide a great solution for your next project. Now I'll hand this back to Patrick, and we'll discuss the deployment of these systems. Thanks, guys.
Thanks, Philip. Yeah, really great overview. I think that really shows why we love these products so much. The flexibility and the versatility that they provide, right? It's so forgiving with so many different types of product. And if your product is not consistent from one to the next, these foam grippers are really going to be very forgiving, right? Since they're able to adapt to the shape. And like we saw, they don't have to be fully covered, right? So they can actually be adapted for multiple SKUs, right? Multiple different sizes of the products as well with a single gripper. So really great. So yeah, next up on our palletizing journey, right? So we've decided that we want to palletize. We've now configured our equipment. We've purchased it hypothetically, right? So next up, we want to deploy the equipment. So how does that work, right? And how does it working with Vention and Joulin? So at the beginning, we mentioned Vention is a manufacturing automation platform. So online, we have all those tools, right? We have all these designs that you can use. So we've looked at how to kind of design and automate, right? Configuring your palletizing cell. We have engineers here at Vention, application specialists that can help out with that as well, to maybe configure some of those more standard solutions that we're showing there. And what's great with Vention too is that whole e-commerce kind of platform aspect, right? So all of the hardware that is used in terms of building up this solution, whether it's the Joulin stuff, maybe the conveyors, the actuators, et cetera. A lot of it is Vention, a lot of it is working through partners. You're basically able to get that from a single source, right? So it's really going to make your life a lot easier being able to purchase just from a single place, not having to track a bunch of different orders and submit a bunch of different orders. So that's that whole idea there. And then finally, let's go into a bit more detail what it might look like deploying a machine like this with Vention. Right. So with each machine like this, essentially you get what we call a deployment package, right? And there's a few different options that we'll talk about, but basically at its core, what you would get, no matter what, is those first three on the left there. So the quick start guide, a user guide, and an integration guide. So quick start guide is, hey, I've received my palletizer, I'm opening it up. Obviously you can get some remote support for that kind of stuff, but just gets you up and running in terms of plugging it in, integrating with your conveyor, and setting up maybe your first pallet to run, right? A user guide will go into more detail about how to use the actual software of the palletizer, how to do some maintenance on it, how to troubleshoot certain scenarios that you're going to get into, how to configure the machine, how to create new pallet patterns, for example. So that's what's in the user guide. And then finally, the integration guide it's kind of the secret sauce, right, of how it all comes together. So at Vention, we use modular components, kind of like industrial Lego, to build up everything. When we build a machine like the Cartesian Palletizer, we're leveraging all of this standard equipment that we've already designed, right? And the integration guide is what shows you how to put it all together, right? Build up the frame, the actuators, where do the sensors go, how does it all plug in together with the controllers, the gripper, the pneumatics, etc. That's what that gives you there, right? And also walks you through a bit of the machine configuration. So if that can seem a bit daunting, right? Hey, I don't want to just receive, a pallet full of extrusions and actuators and put this together. Some people are able to do that, and they can follow the integration guide. They can use a support bundle as an optional add-on for remote commissioning support. Either we'll send it as a full parts kit, or we can send it kind of partially pre-assembled. So that's one option. But obviously, if that's a little daunting and you either don't have the technical expertise or just the time to do it, and you want some more expert help, this is where Vention's Certified System Integrator Network can be so useful and so helpful, right? So we have a CSI network that we've developed in North America and in Europe. And so basically what they're able to help with is on-site deployment. All right, so if you want something a little more turnkey, where basically an integrator will show up on site, the equipment will show up as well. They basically use this integration guide to put together the whole thing. They can even program the pallets that you have, provide a bit of training on how to use the machine, right? How to maintain it, how to troubleshoot it, how to be a little more independent if you need to tweak pallet patterns or do them yourself. That's an option that you have as well, right? In terms of on-site deployment. So just wanted to show all those different options there, what comes, with the actual equipment. And so something that's really cool with Vention as well, and with this particular solution, is that we've actually developed out-of-the-box software that works for this specific application, right? So what we call the Palletizer Machine App. So there's barely any custom coding, right? There's barely any coding at all, for that matter. So it comes out of the box with a machine app that has an intuitive operator UI that runs on this machine pendant that's at the front of the machine there, right? That an operator would interface with. So this is really the screen that an operator would work with, right? So there's not that many options. They're basically just able to pick the pallet recipes, right? So what SKU is going to be run, and then they can click play. It's going to give them some error messages. It's going to show them, or information messages, maybe sometimes errors, hopefully not. A bit of information about where we're at in the palletizing process. How much time is left, what box are we on? We're actually able to start midway through a pallet as well. So it's going to be able to provide that status information as well, right? So that's where an operator lives, and that pendant even has an e-stop there, which is pretty handy. And then next up, that whole code-free aspect is even taken a step further, right? So when you're actually programming, setting up, and configuring the palletizer, it's actually still a code-free experience. So on the left, we have that machine configurator screen. So that's actually a 6-step process that you would go through. Just most machines are very similar, but each one has its particularity, right? Is the conveyor on the left or on the right? How many sensors do I have? What exactly do they do? This is what we want to configure here. This is also where we would configure the speeds, right? So how fast can I actually make this machine go? That'll have to do with the actual weight of your product typically, right? And how well we can actually grip the product based on the gripper selection that we've made. So this is 6-step code-free environment, right? This would be in a configuration place in the UI where only an operator would have access to, right? Or an admin user of the machine. Same goes for the pallet configurator. And this is what's really great. What the machine configurator is typically only something you'll do once when you're self-deploying, or maybe if you have an integrator, right, they would do this once. And then the pallet configurator, this you would do every single time you have a different pallet that you want to do. So if you only have a single pallet to do, great. It can just be done once at initial deployment. But let's say you're changing box suppliers, or the dimensions change a bit, or you want to experiment with different pallet patterns because you want to try to make something more stable, or you're introducing a new product to your line, right? But you still want to use this automated equipment. Having this, again, another 6-step code-free process that lets you go through this graphical user interface to kind of configure the pattern, place your boxes, select your different layers, even select if you want to put a slip sheet separator in between them, really lets you be more independent, right? And not always have to call and get someone to come on site to do this. So really a useful way that we try to kind of enable our users to use their machines to their maximum potential. And so now finally, let's take a look at a couple of case studies from the shop floor where this has all come together so that we can take a look at some real life examples. So this first one here, so this is a single pallet palletizer for 20-pound corrugated boxes, kind of the most generic example you can think of, right? This is just kind of an example pallet we're showing there. The reason it's a couple of pallets stacked high is because this was actually to simulate the fact that in this particular case, there was a conveyor going underneath the machine that was going to be feeding the pallets in automatically. And in this particular case, from the back of the machine is where the boxes would be fed into. And in this particular case, we decided to use a Joulin safe and light gripper. And I'll maybe just let Philip talk a little bit about this one and why it's such a great pick for an application like that.
Yeah, thanks, Patrick. I appreciate that. So this is the safe and light gripper that we were kind of talking about, or that I was kind of talking about before. Mainly made for or manufactured for the collaborative industry. But the nice thing about these grippers is that they're so lightweight. The 120 by 240 actually only weighs 500 grams. And so when you're looking at trying to do some palletizing applications, you really get to utilize the full potential and the full capacity of your system by using these smaller safe and light grippers. Again, they come in two sizes, the 120 by 240 and then the 160 by 320 like you see here. And to be completely honest, they're utilizing the Joulin high flow Venturi cartridge. So essentially all you need to do is supply it with compressed air. And then when you turn the compressed air on, we're using that high flow cartridge so that you don't really have to worry, kind of what I was talking about with those port grippers and the check valve grippers. A lot of times port grippers need to be, nearly covered, about 75%. The nice thing with these safe and lights is that we're using that high flow cartridge so that you really don't have to. You could take and have this gripper halfway covered and still pick a product. I mean, it's awesome. It's really, really a great system. And they're super lightweight. They work really, really well. I think the 160 by 320 actually has a capacity of over 40 pounds. And so it's in most situations, it's going to be way more than any collaborative robot can actually handle. So they're great systems, and they're very safe too. You don't have to worry about somebody getting hit with them necessarily or something to that effect if somebody is around the work cell, because they're very safe. The whole body, the outside body is made of foam for that reason.
And yeah, if I can add to it, like Philip said, right? I mean, you go lighter and basically that lets you go faster at the end of the day, right? So that's why it's so great, even in an application like this that's not necessarily collaborative.
Right.
They also look really cool too with the carbon fiber. And so here's kind of like the most common example that we see of a palletizer. So it's the double pallet palletizer. Like I mentioned, really easy to justify going for that slightly larger machine in terms of how it fits into operations. Obviously, if you can afford the floor space. This particular case is for a slightly more unique product. So these 35-pound insulation panels. So actually more of a kind of wooden surface on the top there, not really regular. Suction cups kind of struggle with this kind of surface. So we actually use the Joulin plug and pick here. And if I just point out to the machine here, obviously, so we see the in-feed conveyor coming in from the left. We kind of see those red lights flashing at us. So those are all the monitoring sensors for product coming in, pallet sensing, product sensing on the pallet. So really a complete solution here. And using the Joulin plug and pick, we had a story of when this was installed and the insulation panel was actually gripped by the gripper. Somebody was actually able to, don't do this at home, but somebody was actually able to stand on top of that insulation panel, and the gripper was able to hold both the human and the panel no problem, right? So these are really strong, and I'll let Philip maybe talk a little about this particular one and some of the features that it has.
Yeah, so the nice thing about these grippers is that they, as you can tell with the bent frame or the broken frame top plate, they're extremely robust. I mean, these grippers are tanks, and the check valves inside, this is a check valve system, so we're able to pick different types of products. There's actually two zones split right down the center of the gripper, so you could actually, if you had a box that was slightly less than 200 by 200 or even 200 by 200, you could actually pick both of those boxes and then palletize them individually just to create your patterns how you want to on the pallet. I mean, it's really a great system. You've got two dry vacuum gauges there, so you can tell the vacuum in each zone. It's really robust system. And as Patrick said, I mean, we've had guys who we would actually pick a pallet with this same gripper, and then some guys out there out in the shop would do pull-ups on the pallet while it was still being handled by the gripper. So I mean, it's a very robust system. It's easy to use. It's easy to integrate, and the maintenance on it is very, very low. Since we don't have screens, we don't have filters or anything like that. Essentially, you just need to have a schedule of when you need to change your foam out, and that's about it.
Yeah, awesome. So that, yeah, really a great gripper, and that's the one that we like to use actually in most cases for its versatility. So hopefully we've given you a good look at kind of how to go about automating palletizing with a Vention and Joulin cartesian palletizing system. At a fairly high level, we're obviously happy to field any more technical questions or field any questions that you might have had along the way.
That's a good segue, Pat. So thank you both, Pat and Phil, for an excellent presentation. On that note, we do have a couple questions, some more specific to Phil and maybe others to Pat. One, and it addresses Phil's last comment, is how long does foam typically last on a gripper?
So this is just going to be dependent on the project, obviously, and how what you're picking and so on and so forth, and what your motion profiles are and whatnot. But generally, in most situations, for a 40-hour work week, we're going to see approximately 2 to 3 months foam life. But there are situations where we see 6, 8, 12 months of foam life, and it all comes down to how you're utilizing the foam gripper and how you're compressing the foam and so on and so forth. So typically it's going to be about 2 or 3 months though for a 40-hour work week.
And there's a follow-up question to this. It's a good one. Is what is the weight capacity? If you said a human could stand on one, do you have a typical weight capacity for the gripper system?
So again, that's going to depend on your size, because essentially it's just math at that point. A 1,000 millimeters by 1,000 millimeters at 100 millibar can essentially pick 1,000 kilograms. That's the math behind it. That would be obviously a large gripper, a large cup, and essentially that's not including any safety or anything like that. But just for reference, our 200 by 400 gripper is rated to handle rigid non-porous parts weighing up to 300 pounds, and then some porous parts up to 100 pounds. So essentially anything like a stainless steel sheet, it could, essentially that's 135, 136 kg. And then like a box or a porous part like some wood or something like that, about 45 kg. So very, very strong grippers. And again, it just depends on what you're trying to do and how large the gripper is.
Not to pick on you, Phil, but I think everyone's quite interested in the grippers. Are there particular environments where the grippers are most, let's say, successful? So temperatures, what are the temperature variances?
Right. So the temperatures that these grippers can withstand, and this is basically going back to the foam. Specifically, the foam is rated to work in intermittent contacting temperatures of negative 40 degrees Fahrenheit or Celsius, which is also Fahrenheit. That's where those two temperature ranges meet. And then up to 129 degrees Celsius or 265 degrees Fahrenheit. So that's the foam. We have to be a little bit cautious on our check valves and some of the internals, because some of the check valves are rated, I think, around 200 degrees Fahrenheit. And so we would need to be a little bit cautious about that. But again, you're talking about picking stuff straight out of an oven, if you're looking at that. In most situations, the environments that we're dealing with, as long as the air that you're supplying the tool, in other words, the compressed air, as long as it's dry, then you could have a really dusty environment, dirty environment. It could be really, really nasty part, and we'll still be able to handle it well in most situations. But essentially, if somebody was asking the temperature range, negative 40 to about positive 129 Celsius would be the temperature range that our grippers are going to work efficiently in.
Very good. One question I think Pat might be able to answer best is related to the speed of the solution. So how fast can these palletizing solutions actually operate?
Yeah, thanks, Jen. So Basically, I mean, the max of the Cartesian palletizer that we were taking a look at today is 4 boxes a minute, right? There's a bunch of parameters that will obviously come affect that, like the type of product, the payload, the porosity of the product, etc. You could also, do multi-pick like we mentioned, right? So if you're able to pick 2 boxes at a time, then you can do 8 boxes a minute, right? But the straight answer is it will pick at a maximum 4 boxes a minute.
Interesting question. So naturally, our audience probably has a variety of different products that they handle. So one participant would like to know, how can they be sure that the palletizer will work for their particular product?
Yeah, sure. I'll field that, and I think Philip can probably add on to that. But I mean, the best way is essentially obviously lean on the expertise that Vention and Joulin has, but send us the product and we'll test it, right? At no additional cost. Vention has a setup in our applications lab here. We have a Cartesian palletizer operational. We can even run a trial pallet if that's what we need to do. We have a few grippers here, although obviously we work with folks like Joulin for those really tricky edge cases to make sure that we're confident that it's going to work. So yeah, I mean, the best way to be sure is test it, right? And let's see what happens.
Yeah, yeah, and definitely just to add to that, I mean, that's one of the things that Joulin is really important to Joulin is testing applications beforehand, because Joulin has a tenacity when it comes to these types of projects or any types of projects that we approach, because we really want our systems to be out in the field functioning properly the way that we guaranteed that they would, and that's essentially coming from Joulin. So we have a full lab of testing material, testing facility, where we can test several different grippers in our arsenal essentially, and we also have a 6-axis 225 kg capacity robot that we can move product around at speed, and we can take video and send those videos to Vention, and they can edit the videos and then also add their parts as well. And so we can really give you a good amount of I don't know how to say it, confidence going into being able to handle your product. You send it to us, we'll handle it, and then we can all work together to make sure that it's going to work efficiently and effectively.
Yeah.
I'm looking at the Q&A, and I think I have one last question, and it looks to be the $1 million question: is how much does it cost?
Yeah, of course, the $1 million question. So Vention, like I was mentioning, right? So we're a web platform. We actually list all the prices directly on the website, so you can go there. Obviously, I won't make you go there now. These particular palletizing solutions will start just for the hardware at around 95,000 US. Obviously, when you start adding options, shipping, maybe integration services for on-site deployment, etc., that can go up to maybe around 130,000, right? So expect anywhere from 90 to 130,000 or in that ballpark in US.
Great. Well, one last scan. It looks like that is the end of our questions. So without further ado, I would like to thank you guys again for delivering such an excellent presentation. I myself found it quite insightful as well. A reminder to the participants that an on-demand version will be available and sent to everyone. So keep an eye out on your inbox for that, and we look forward to the next webinar.
Thank you, Jen. Thanks, Philip.
Thanks, everybody. I appreciate it very much.
Have a great day.
Have a great day.